so let's summarize all of this stuff about sine, cosine, and tangent. So you have yourself a right triangle. In that right triangle, one of the angles is the one that we're going to be referencing. This is the Greek letter theta. And it's a Greek letter that we often use for angle measurements. That's what we're going to use for this lesson. So after you have yourself a right triangle, you want to label the sides, starting with the hypotenuse, directly opposite the right angle. Now, if I take this angle measurement right here at theta, opposite that side, CB, is called the opposite side. The side that it touches that's not the hypotenuse is called the adjacent side. Now we have three trig ratios. The first one is sine. And the sine of theta is going to be the opposite over the hypotenuse. The cosine of that angle measurement is adjacent over hypotenuse. And the tangent finally is opposite over adjacent. Now notice in every single one of these, whenever you take the sine, the cosine, or tangent of something, it's always an angle measurement. And it's always one of these acute angles, like either A or C. It's not ever the right angle. Okay, now you're going to have these things memorized. So here are a couple of ways to memorize this. If you look on any scientific calculator, sine, cosine, and tangent always come in this exact order: sin, cos, and tan, no matter where it's made. So here's the first way to memorize this. If you write them in order, sine, cosine, and tangent, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, you can remember it like this. Oh hell, another hour of algebra. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. In most math classes or in science classes like physics class, usually what you learn is SOHCAHTOA. So for the sine, opposite over hypotenuse, ka for cosine is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. If you want to, you can try to find me a t-shirt. I wear a men's small on maybe Camp SOHCAHTOA. You could probably find that on the internet someplace. Okay, so on this example, example 3, I've got two different angle measurements. This is a Greek letter alpha. This is the Greek letter beta. First, let's complete the right triangle. It's a 3, 4, 5 right triangle. First, using angle A, alpha, I'm going to label our sides. Here's the hypotenuse. The 3 is opposite, and the 4 is the adjacent side. It's the one that's touching alpha, but it's not the hypotenuse. And we're going to write not the 6, but the 3 trig ratios: the sine of alpha, the cosine of alpha, and the tangent of alpha. So all I have to do is substitute the numbers in for whatever the ratio is supposed to be. Sine is opposite over hypotenuse. Oh hell. 3 over 5. Cosine is adjacent over hypotenuse. 4 over 5. And the tangent is opposite over adjacent. 3 over 4. Okay, so now let's switch angles to the sine, cosine, and tangent of beta. The only thing that switches whenever I switch instead to angle B, the beta, now the 4 is the opposite side and the 3 is the adjacent side. So when I find the sine of beta, the sine is opposite over hypotenuse. It becomes 4 over 5, which is the same thing that I had for the cosine of alpha. Cosine of beta should be adjacent over hypotenuse, which is 3 over 5. It's the same thing I had for the sine. And then finally, tangent opposite over adjacent, 4 over 3. It's the same thing as this one, just flipped over, because I switched the opposite and the adjacent sides.